Hello friends, thank you very much for watching this video. This is Shivani Bopatra Rohai and thank you very much for visiting this channel Saving. Now in this video we are going to learn about a new type of distillation which is known as the fractional distillation. Now in this video we will know that what is fractional distillation and how it is done to separate different organic liquids. Now fractional distillation is used for the separation of a liquid of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin. And the apparatus for fractional distillation is similar to that of simple distillation, except that a fractionating column is fitted in between the distillation flask and the condenser. So, now the schematic representation of fractional distillation is shown here, and the only difference of this distillation from simple distillation, as we have learned in the earlier video, is that a fractionating column is fitted in between the condenser and the round bottom flask. Now the first step is that we have to heat the system containing the two liquids, that is A and B, and here the main point is that the boiling points of A and B are very similar, but the boiling point of one of the components, suppose A, is slightly less than that of B. And in the second step we can see that since the boiling point of A and B were very much similar to each other, so both will vaporize, which is not in the case of simple distillation. And here both vapors of A and B will be present in the system, which will move further through the fractionating column. Now a fractionating column is a tube packed with glass beads, and the beads provide surface for the vapors to cool and condense repeatedly. And when the vapors of a mixture are passed through the fractionating column, because of the repeated condensation and evaporation, the vapors of the liquid with the lower boiling point first pass out through the fractionating column, condense, and are collected in the receiver flask. So here we can see that as the A was the low boiling component and B was the high boiling component, due to interaction with the different surfaces provided by the fractionating column, B loses heat, and so it no longer remains as a vapor form, and so B liquidifies. So the vapors can be separated from the liquid easily, and further the vapors are cooled to form liquid form of A, which is actually its pure form, and in this way the A was separated from the system. And in other way, if we see that when the vapors of A were separated from the system, only B was left out, so B can be collected in the pure form. Now this is the diagrammatic representation of fractional distillation. Now this is the round bottom flask containing the two liquids to which heat has to be provided. This is the fractionating column. Now this is the condenser, which is required to maintain a low temperature. Now this will be an water outlet through which water will flow out to the sink, and this will be the water inlet through which the water will flow inside the condenser. Now let's review the steps. So at the first step is that we have to apply heat to the round bottom flask containing the two liquids A and B, and since the boiling point of them are very similar, so in the first case both A and B will form vapors, and that vapors of A and B will tend to move towards the mouth of the round bottom flask, towards the fractionating column. Now this is the fractionating column containing maybe glass beads, and this will provide many surfaces which will allow heat exchanges between the vapors. And due to loss of heat by the higher boiling component, it will liquidify, and hence only the vapors of A will be remaining in the fractionating column, which will pass through the condenser. And due to the low temperature of the condenser, the vapors of A, it will liquidify and form droplets which can be collected in a receiver flask shown in the picture, and in this way we can collect the pure form of the low boiling component, that is A, and the rest which was we have not collected is the component B, that is the high boiling component, which will remain in the first round bottom flask, and in this way we can separate the two liquids having comparable boiling points. Now in this picture we can see there are two different types of fractionating column shown at the extreme left picture. Now the first one is the simple packed fractionating column, which is composed of glass beads which provide the surfaces, and this second one is the bubble plate fractionating column, and a unit is shown here in an expanded form which is known as the theoretical plate, and the arrows are the direction of how the vapors are passing through the unit. Now a theoretical plate is a successive condensation and vaporization unit in a fractionating column. Now in this way we can separate different liquids having similar boiling points by fractionating column. And so thank you very much for watching this video. Please like, share and subscribe, and thank you very much.